All right, let's get right into it. If you're gearing up for the 398 electrician exam, you are in exactly the right place. Consider this explainer your personal masterclass. As a master electrical inspector, I've seen countless apprentices stumble on the exact same types of tricky questions. Today, we're not just going to give you an answer. We're going to wire your brain to think exactly like an inspector. We'll strip away the confusion and build up that code knowledge so you can walk into that exam room with absolute confidence. So let's look at a prime scenario specifically designed to test your actual understanding of the rules rather than just your ability to memorize tables. What is the minimum size of copper grounding conductor required to run between the two rods when using a manufactured grounding electrode, consisting of two rod electrodes for a 120/240 volt, 60 amp one-phase service? A. No, 8 AWG. B. No, 6 AWG. C. No, 4 AWG. D. No, 3 AWG. We're going to break down the code on this right now. If you want to get licensed, hit that like button and subscribe for more daily sample questions. Now, what's really interesting here is how we separate the absolute facts from the distractions. When you're sitting in that exam chair, the clock is ticking, and the examiners, they know exactly how to induce panic. And they do it by completely overloading you with data. Look at the red herring distractions we're dealing with right now. 120/240 volts, 60 amps, one-phase service. Your brain immediately wants to jump straight to Section 8 or Section 4, trying to calculate ampacities or size service conductors. But hold on. Let's isolate the actual keywords: grounding conductor size, copper, and manufactured grounding electrode. Just by doing that, we change the entire landscape of the question. We're no longer sizing a service, guys. We're sizing a very specific connection to the earth. And this brings us right to the absolutely crucial difference between system grounding and equipment bonding. That 60 amp service detail, yeah, that's a deliberate trap. You see, bonding conductors are sized based on the overcurrent device, right? They need to be massive enough to carry massive fault current back to the source to trip a breaker. But system grounding, its primary job is to create a common reference to Earth and stabilize voltages. It connects to a manufactured grounding electrode, like the two rods mentioned in our scenario. Because the Earth itself has a relatively high resistance, a massive amount of fault current won't typically travel through this specific wire anyway. So the minimum copper size to Earth is dictated by a strict baseline rule in Section 10, not at all by your service's ampacity. And this brilliantly illustrates exactly where we find our answer in the Canadian Electrical Code. We're looking at Rule 10-114, Subrule 1, Item A. It states plainly, except as permitted by Subrule 2, the grounding conductor shall be sized not smaller than A. No 6 AWG if of copper. Boom. This is your undeniable rock-solid standard. Whether you have a 60 amp service or a 200 amp service, it literally doesn't matter. If you are running a copper grounding conductor to a standard manufactured electrode, like a ground rod, the absolute minimum baseline to establish that safe connection to the dirt is a no 6 AWG copper wire. The code sets this size to make sure the wire actually has the mechanical strength to survive being buried and exposed to the elements, while having the electrical capacity to handle lightning surges and stabilize the system. So if there's one pro tip I can absolutely drill into your head for this exam, it's this. Do not let load data trick you on primary grounding electrode questions. The examiners are going to throw numbers at you all day long, voltages, amperages, phases, just to see if you'll take the bait and start sizing a bonding jumper instead of a grounding conductor. When the question asks for the connection going straight into the dirt, to the rods or plates, you immediately pull back. Ignore the service-size distraction and remember Section 10's baseline rules for copper and aluminum to Earth. All right, bringing it all back to our original scenario, the fog has completely cleared. We're looking for the copper grounding conductor connecting the two rods of a manufactured grounding electrode. So what do? We ignore the 120/240V, we completely ignore the 60 amps, and we ignore the one-phase service data. Relying purely on Rule 10-1014A, we know the minimum size required. The correct answer is option B, no 6 AWG. That is the standard, that is the code, and honestly, that is exactly how you navigate an exam question without falling into the traps. Don't leave your license to chance. For full 309A prep courses and hundreds of practice examples, head over to averdosh.com. Get it done right the first time. I'll see you in the field. But before you go, ask yourself this. If they can trick you on a basic ground rod connection, what other massive traps are hiding in Section 10? Keep studying and stay sharp.
For more sample question, follow us.